I'm Dana Shagru with CEA World Greenhouse Produce, an innovative brand that engages with the rapidly expanding global greenhouse produce industry through a variety of platforms. Our mission is to educate and connect greenhouse produce growers and industry allies to help them better understand and sustainably advance the global food industry. On this episode of CE Ag Talks, I'll be speaking with Shreyas Kusik, an assistant professor in mechanical engineering at Georgia Tech. Shreyas, welcome to CE Ag Talks.
Thanks so much, Dana. I really appreciate the chance to get to talk a bit about robotics and how it can potentially make an impact in the controlled environment agriculture world.
Yeah, I'm excited to talk about it too. So, yeah, like you said, we'll be talking about how robotics can be applied in controlled environment agriculture and the different problems that growers can run into and potential solutions that robotics could bring to the table. So, my first question for you is, can you tell us a little bit more about yourself and how a mechanical engineer got involved in the CEA industry?
Yeah, sure thing. So I've grown up in the Southeast. My dad is well, now he's a research scientist, but for the longest time, he's been in agriculture. So I've, in some sense, grown up around it. And I think because I was so close to it, I specifically wanted nothing to do with it until very recently, where maybe to answer the last part of the question, how did a mechanical engineer get involved? I think earlier this year or last year, I had the chance to visit where my dad works in the USDA and chatted with a few of his colleagues. One of those colleagues, Kai Shuling, showed me this indoor growing facility. And the technicians there were mentioning several of the things that they have to do day to day, many of the um, maybe regular day-to-day tasks that are required to get one of these indoor farms or controlled environment agriculture. This was, I guess, a converted tractor trailer, but to get one of these things up and running and then to keep it going takes tons and tons of manual labor and daily labor. So I felt inspired as someone who works on robotics and has never really thought about agriculture. I was like, well, a lot of these tasks seem like a reasonable place to try and get a robot to help. The actuality of it is that these tasks are very, very challenging for a variety of reasons that we can go into soon. But just to give you a feel, what we were talking about there was planting, or I guess installing plants in a hydroponic growing facility and then pruning them to make sure that they're growing well, cleaning up the pruned results like the leaves and detritus that falls from that. So that's regular. Then pollinating plants. So for certain facilities, you can't keep bees or natural pollinators inside of them. Finally, hopefully your fruit grows well, and then you have to harvest it. Harvesting is its own classical robotics problem, where I think quite a few companies have worked on a variety of crops, mostly strawberry and tomato that I know of. And then finally, just clean up. Like once your crop is done, it's got to get cleaned up. You have to sanitize everything, take apart a lot of the hydroponic stuff, sanitize it, and put it back together. So that's like the full scope of very complex dexterous manipulation tasks. Dexterous manipulation meaning that like you use your hands a lot. The way I got involved then was to say, hey, maybe a robot can do some of these things. And it turns out it's extremely challenging, but it's a great place to extend the front of robotics knowledge.
Well, to kind of piggyback on that, you mentioned the tasks that require dexterity, and that makes tasks that are easy for humans difficult for robots. Can you explain how that statement kind of applies in CEA?
Yeah, I think maybe the best example is harvesting. It's something that I think a lot of people are familiar with, even outside of agriculture. So when you harvest, especially like a berry, it requires you to not crush the berry. And usually there's a twisting motion or you hold the stem. I mean, the best humans at harvesting this are extremely efficient, right? They know exactly how to gently hold the berry, twist it off of where it's attached to the plant, and then use enough force to actually pull it. So this is a combination of like low force motions to touch the fruit and high force to either push through foliage or pull the fruit off of the plant. It's really, really challenging to do these types of contact-rich interactions because typically, I mean, even the nicest robot hands don't have the same level of nerve or tactile sensation that a human does. Beyond that, making sure you're controlling forces correctly and then understanding the semantics of like, I am picking a fruit. I need to know what fruit look like. I need to be able to perceive them reliably. And then when in contact with them, contact them in a robust and reproducible way. all of these are tremendously challenging across the spectrum of robotics, from designing hardware that can do this type of tactile sensing to designing algorithms that can perceive fruit reliably and then physically interact with a plant. One of the hardest things that I think this is across any sort of organic interaction or anything that's grown, having a robot interact with it is very challenging because these are fundamentally deformable objects. And you see this across robotics. So there's a whole field of study of how do you help somebody wear a shirt? It's pretty easy to model most robots because they're rigid bodies and we have pretty well-defined mathematical models. It is very, very hard to mathematically model a t-shirt. And for the exact same reason, even more complex than the t-shirt is a plant, which has parts that are very soft, very rigid. The fruit itself is a combination of soft and rigid parts. And the best mathematical models we have of those typically take hours to solve. For, if you want to simulate the squishing of a fruit, that may take hours to solve, but you have to do it really, really quickly with a robot that's in the field. So fundamentally, maybe to summarize, the challenge in getting a robot to work in a controlled environment agriculture facility is the robot has to handle the squishy, uncertain world that we humans are very, very well adapted to.
Now, I know the opposite is true for robotic tasks. Tasks that are easy for robots aren't easy for humans. Can you give some examples of those in a CEA operation?
Sure. Yeah, so anything to do with repeated motion that you can pre-program, that's like the easiest thing for a robot to do. The maybe the canonical example from robotics is moving a car chassis in an assembly line or installing a heavy part. The funny part about it is that you'd have maybe a robot arm move a car chassis into place or a car door into place, and then a human comes in and actually installs the nuts and bolts that hold the door on. This is not in every facility, but certainly this is one way of getting robots to help. It's heavy lifting and repetitive tasks. So where this may be really, what we're seeing in controlled environment agriculture, places that this can happen, where a robot can really make an impact are, for example, taking photographs of plants. So there's work at Georgia Tech from my colleagues, Frank Dellert and Yongshan Chen, where they have a cable-driven robot that can take, hundreds of photos over the course of hours in a way that I think if you asked a person to do it, they would say no. They would get very, very tired standing over every single plant. And on top of that, the reproducibility of taking the same photo from the same location of a growing plant is just super, super intractable for a human to do. So that's an example where maybe there's no heavy lifting involved, but it's a tedious and extremely repetitive task. That isn't to say that every maybe tedious or repetitive task is easy to automate. For example, fruit harvesting, as you mentioned earlier, many people may think it's very tedious and very repetitive, and certainly it's repetitive, super hard to automate for the aforementioned deformable interaction and perception challenges.
Thank you again, Shreyas, for joining me this afternoon. And we look forward to seeing how robotics continue to affect the CEA industry. And I'm sure we'll talk again soon.